right, let's look at factoring quadratics. Now, here's what I mean when I say factor. I'm talking about finding the two things or three things that were multiplied to get a given quantity. Now, let's look at a number example to try to understand this. If I look at 12, then I could say that 3 and 4 are factors of 12. I could also say that 2 and 6 are factors of 12, because when I multiply 6 and 2 together, I get 12. And when I multiply 4 and 3 together, I get 12. And you see here on this slide other examples of factors of 12. So then when we factor something, we find the things that we can multiply together to get the given quantity. Now we're going to talk about factoring trinomials or quadratics. Those two terms, trinomials and quadratics, are synonymous. They mean the same thing, and so I will use them interchangeably. Now let's look at the process for factoring trinomials. If I have a standard form equation in the form ax squared plus bx plus c, where a is equal to 1, then I'm going to use this process to factor that. First, I'm going to take a look at this constant value c, and I'm going to find two numbers that are factors of c. In other words, I'm going to find two numbers that when I multiply them, they equal to c. And so I'm also going to look for two numbers that when I add them, they're equal to b. So I'm going to find two numbers that multiply to be c, and those same two numbers, when I add them, they're equal to b. Now, once I find those two numbers, I'm going to use those numbers to write my factors. X plus the first number, and then x plus the second number. Now, pause now and make sure that you have written this process as it appears on this slide in your notes. Now, there are also some helpful clues that you can use to help determine which factors to use. Here is clue number 1. If C is positive, then if B is positive, then both of the numbers you're looking for are going to be positive. And if C is positive but B is negative, then both of those numbers are going to end up being negative. Now, let me clear this up with a little chart. In this case, C is positive, but B is negative. That means that the two numbers you're looking for are going to be negative. In the other case, C is positive, but B is also positive, so both of the numbers you're looking for are going to be positive. Pause now and make sure that you have taken notes on everything that is on this slide. Now it's time to take a look at two quadratics and actually use our process to factor them. Now we're going to start with this one. In this case, C is positive 6, and also I'm going to ask you to notice that B is negative. So the two numbers we're looking for are both going to be negative. Now, step 1 of our process was to find two numbers that multiply to be 6 but add to be negative 5. So let's start factoring 6 and see what we get. We're going to just start with 1 times 6 and work our way up. 2 times whatever makes 6 and work our way up until we find the factors that work. So I started with 1 times 6. That doesn't work because it doesn't add to be negative 5. I have 2 times 3 now, and that definitely multiplies to be 6, and it adds to be positive 5, but I need negative 5. So I'm just going to make both of those negative, and they will add to be negative 5. So now I have negative 2 times negative 3. That is equal to positive 6. And I have negative 2 plus negative 3, and that is equal to negative 5. So I found my two numbers, negative 2 and negative 5. Negative 2 and negative 3. I'm going to use those to write the factors for this trinomial or quadratic. And they are x minus 2 times x minus 3. What this means is if I multiply these two binomials together, I'm going to get x squared minus 5x plus 6. Now, why did I go through all this trouble of factoring? I went through all this trouble of factoring because it is a method that you can use to solve for x given a quadratic that looks like this. I can actually solve for x by factoring. So how do we get from having the factors to solving? Here's what we do. We're going to strip off the parentheses and set each one of our factors equal to 0. So I have x minus 2 is equal to 0, and x minus 3 is equal to 0. And then in both cases, I'm going to solve for x. So in this case, I add 2 to both sides, and in this case, I'm going to add 3 to both sides. And I end up with x is equal to 2, and x is equal to 3. Those are my x-intercepts at x equal 2, y equals 0, and 3, x equal 3, and y equals 0. Those are the x-intercepts for this quadratic. The x-intercepts are where we find the solution. So now I have used factoring to solve for x in the case of that quadratic. Now let's take a look at this next example, x squared plus 5x plus 6. So in this case, c is positive and b is also positive, so the two numbers I'm looking for will be positive, and you've probably already guessed what they are. 2 times 3 definitely adds to be 6, multiplies to be 6 and adds to be 5. So my numbers are positive 2 and positive 3. So in this case, I can use those two numbers to write my factors x plus 2 and x plus 3, but I'm not going to stop there. I want to use my factors to solve for x for this quadratic. So what am I going to do? I'm going to take each factor and set them equal to 0, and then I'm going to solve for x. In this case, I'm going to subtract 2 from both sides. In this one, I'm going to subtract 3 from both sides. Going to end up with x is equal to negative 2 and x is equal to negative 3. And that is going to give me my x-intercepts of negative 2 and 0 and negative 3 and 0. In other words, if I graph this parabola, I would get x-intercepts at these 2 points. Now pause now and make sure that you have copied down both of these examples, every single step. Take any additional notes based on what I've said, but make sure both of these examples are in your notes. Now, clue number 2. If c is negative, then one of your numbers is going to be positive and the other one is going to be negative. Now, if b is positive, then the larger of the two numbers is going to be positive. And if b is negative, then the larger of the two numbers is going to be negative. So here is a chart that will help you remember that for these two cases. If c is negative and b is negative, then the larger factor is negative. But if c is negative and b is positive, then the larger of the two factors is positive. Please pause now and make sure that you have this slide well documented in your notes. Now let's take a look at these two examples of factoring. So I'm going to start with x squared minus 1x is minus 12. So I have negative c and negative b. So that means the larger of the two numbers I'm looking for is going to be negative. So I'm going to find two numbers that multiply to be negative 12 and add to be negative 1. So let's see what I got here. If I start with 2 times 6, that doesn't work. 3 times 4, that has some possibilities. It definitely multiplies to be 12, but I need negative 12. So I need one of these numbers to be negative. Now, my clue says the larger of the two numbers should be negative. So I think I'm going to make 4 negative. So now when I multiply 3 times negative 4, I get negative 12. And when I add 3 plus negative 4, I get negative 1. That meets my requirements. Those are the two numbers that I'm looking for. And so I'm going to use those to write my factors. If I multiply x plus 3 together, x plus 3 times x minus 4, I'm going to get x squared minus x minus 12. But I don't stop there. These are just factors. These are not solutions. So to actually get the solutions, I'm going to take each factor, set it equal to 0, and in this case, I'm going to subtract 3 from both sides. In this one, I'll subtract 4 from both sides, and then get my answers. X is equal to negative 3, and x is equal to positive 4. These are my x-intercepts and the solutions to this trinomial. Now let's take a look at this case. In this case, C is negative, but B is positive. So the larger of my two numbers is going to end up being positive. All right, so let's break down C and see where we're at. So again, I get to the numbers 3 and 4, but I need the larger of these to be positive. So I'm going to go ahead and make 4 positive and 3 negative. Now, negative 3 times 4 definitely ends up being negative 12, and negative 3 plus 4 is 1, and that meets my requirements. So I'm going to use those two numbers to write my factors. Then I'm going to set them both equal to 0 and solve for x and get my x-intercepts of 3, 0, and negative 4 and 0. In other words, if I graphed this parabola, I would see it crossing the x-axis at x equal 3 and x equal negative 4. Pause now and make sure that you have every single step of these two examples documented in your notes. Now there are a few special cases. Now one special case is when you don't have a y, well, your y-intercept is 0, when c is 0. Now these quadratics look like this. 3x squared minus 9x, these are good examples, or 2x squared plus 12x. You notice there's no c. In that case, it's all about finding the greatest common factor. Now, in the case of the first example, the greatest term, the largest term that would divide into both 3x squared and 9x is 3x. It's common to both. If I factor that out, I end up with reverse distribution, like the distributive property in reverse. I end up with 3x times x minus 3. Now, if I apply the distributive property to that, you could see I'd get 3x squared minus 9x. So now that I have my two factors, I'm going to set them both equal to 0 and solve for x to get my x-intercepts. And so in this case, the x-intercepts are 0, 0, and 3, 0. If I look at the second case, the largest common factor that would divide into both is 2x. And so I'm going to factor out 2x, set both factors equal to 0, solve for x, and that will give me my x-intercepts. In other words, if I graphed this parabola, I'd end up with the graph crossing the x-axis at 0, 0 and at negative 6, 0. And in this case, it would cross the x-axis at 0, 0 and 3, 0. Pause now and make sure that you have everything documented on this slide in your notes. Now, if you have any questions at all or were confused, be sure to note your questions. You can email me, or you can come see me, or we can talk about it in class. Come to class ready to practice factoring quadratics. Thank you.